My name is Dan Kwema Okenji, and I welcome you to Ken Tech 96 TV. For today's lesson, we are going to talk about what we call physical quantities. And this is a subtopic under physics, and this is for science students, those studying physics. And when we talk of physical quantities, they are quantities that can be measured or observed. When we talk of a physical quantity, any quantity that you can measure or observe is what we call physical quantity. Examples is what we call distance. Remember, we can measure the distance between two objects using what we call meter rule. We can use meter rule to measure distance. We can also use micrometer, screw gauge, and vernier caliper to measure distance. We can also measure time, because time is also a physical quantity. And to measure time, we can use what we call the stop clock or watch to measure time. And finally, we can also measure the length. We can measure the length between two objects. So any physical quantity or any quantity that can be measured is what we call physical quantity. So let's look at the types of physical quantities. There are two types of physical quantity. One is fundamental quantity and the other one is derived quantity. So when we talk of fundamental quantities, they are quantities which are independent of any other quantities. So these are the quantities in which all other derived quantities are obtained from. Examples of fundamental quantities, we have about 7 fundamental quantities, of which I will take my time and explain them one after the other. And when we talk of derived quantities, they are quantities formed by the combination of two or more fundamental quantities. So whenever we combine two or more of the basic, by the way, another name for fundamental quantity is what we call the base quantity. So anytime we combine base or fundamental quantities, we arrive at what we call derived quantity. For example, time, length, they are all fundamental quantities. But we can combine time and length to obtain what we call derived quantity. An example of derived quantity is velocity. Velocity is a derived quantity, which is change in distance with respect to time. So velocity is equal to distance over time. Distance is measured in meters. Time is measured in seconds. So velocity is equal to meter per second. So remember, velocity is a derived quantity because we combine two or more of the fundamental quantities. So let's dive deep and go into the analysis of fundamental and derived quantities. Talk about fundamental quantities. They are quantities in which other quantities are obtained from. And per definition, fundamental quantities are quantities which is independent of other quantities. In mechanics, mass, length are called fundamental quantities. The same way, when we go to matter, amount of substance, which is mole, is also a fundamental quantity. In heat, temperature is also a fundamental quantity. In current and electricity, electric current is also a fundamental quantity. Now, there are 7 basic fundamental quantities, and these are the 7 basic fundamental quantities, together with their unit of measurement. So if you want to measure length, the unit should be in meters. If you want to measure mass, it should be in kilograms. So the same value, which is 10, the moment I write 10 m, this should tell you that it's in meters, so 10 meters. The same 10 kg, this should tell you that it's not length again, it's in kilogram, which is what? Mass. If it is 10s, which is seconds, 10 seconds, it should tell you that it's time. So fundamental quantities, we have what? Length measured in meters, mass in kilogram, time in seconds, temperature in Kelvin, electric current in ampere, luminous intensity, which is candela, amount of substance or quantity of matter, which is mole. Now let's also move on to derived quantities. Then another type of physical quantity is what we call a derived quantity. And for derived quantity, they are obtained by combining two or more fundamental quantities. So per the definition, the quantity which is derived from the fundamental quantity. So if you have a fundamental quantity, you can obtain the derived quantity from the fundamental quantities. An example is area. So here, area can be equal to length, let's say area of a square, which is length times length. So here we have meter times meter, which is meter square. So when I combine two lengths, I'm going to have what we call meter square, which is a derived quantity. Now, speed. When I combine distance and time over time, which is distance is measured in meters over time, which is measured in seconds. So I'm going to have meter per second. So here, speed is also a derived quantity. Now, when we talk of density, density is equal to mass over volume. So here, mass is a fundamental quantity, but volume itself is a derived quantity because under volume, we've combined length times length times length, which is equal to meter cube. So that's why density is having a unit of kilogram per meter cube. Then pressure is also a derived quantity. So let's dive deep into dimensional analysis. We want to look at dimensions. So first, let's talk about dimensions. Then we finally continue with dimensional analysis. But dimensional analysis will be in our next chapter of will be in lesson 2. So let's conclude this chapter with dimensions. Of dimensions, we have one, dimensional constant. So there are some variables with constant dimension. Example, when you have a gravitational constant. Gravitational constant has a fixed dimension. The second one is dimensional variable. So there are variables with what? Dimensions. So example is velocity. And velocity is what? V. So the dimension for velocity. Remember, velocity is distance over time. So velocity is L over T, which is LT minus 1. Then we have dimensionless constant. So these are variables with no dimension, especially if you have pi. Pi has no dimension, or numbers 1, 2, 3, 4, 5, 6, they all don't have dimension. Then we have what we call the dimensionless variable, especially one is what? Angle and strain. So when we talk of angle, 36 degrees, 36 degrees, let's say Celsius, which is, let's say, the temperature of a human. And this is dimensionless value. It doesn't have any dimension. So let's take more examples of dimension and end this session. Let's talk about dimensions, or let's end this session with dimensions. When we talk of dimensions, the powers to which the fundamental units of mass, length, time, written as M, L, and T, are raised, which include their nature, not magnitude. So when we talk, remember we said for fundamental quantities, we have 7 fundamental quantities. And when we talk of mass, it's measured in kilograms. So mass has a dimension of M, capital M. So the dimension, the same dimension for mass is M. Then when you talk of dimension of length, length is written as capital L. Then dimension of T, which is time, is capital T. So when we talk, so these are the dimensions for the fundamental quantities. So if you want to write the dimensions of derived quantities, remember We obtain derived quantities by combining the fundamental quantities. So if I want to write the dimension for, let's say, density, density is equal to mass over volume. Now, when I want to find the dimension of density, I need to first find the dimension of mass and also the dimension for volume. And the dimension for mass is capital M. Dimension of volume. Remember, volume is length times length times length, and length is L. So we are going to have L3. So therefore, dimension of density is going to be, so let's say dimension of density is M over L3, L raised to the power 3, which is equal to M L raised to the power 3. Then let's quickly talk about the classifications of dimensions. Then we take more examples on dimension. Let's derive the dimensional formula of the following quantities. And the first one is moment of force. And moment of force is equal to force times distance. So we need to find the dimension of force, and we also find the dimension of distance. So to find the dimension of moment of force, we need to find the dimension of force, which is equal to, force is always giving us mass times acceleration. So for you to calculate your mass, and the dimension for mass is m, acceleration is Lt minus 2. Then the dimension for distance is also L. So for moment of force, we are going to have Lt, moment of force m Lt minus 2 times L, which is equal to m L squared T minus 2. So this is the dimension for moment of force. So let's move on to momentum. Then for number 2, we are supposed to find the dimension for momentum. So momentum. And remember, momentum is giving us, momentum is equal to mass times velocity. And the dimension for mass is capital M. Velocity is Lt minus 1. So to calculate the dimension for momentum, we are going to have m Lt minus 1. Anytime you want to calculate for dimension, what you need is the formula. You first need to find the formula. Then you find the dimension of the respective variables in the formula before you finally proceed to find the dimension of the variable given in question. Thank you for watching Kentech 96 TV. Please, if you are new to this channel, kindly subscribe. And in our next video, we will dive deep into what we call dimensional analysis. So we look at the advantages or importance of dimensional analysis, and that is where we check the validity of an equation, derive equations from quantities, and a whole lot of things.